Good morning students. Today we are going to perform fifth practical of basic electronics, that is linear applications of OPAMP. IC number is 741. In that we are going to perform inverting and non-inverting operational amplifier. Why the name is operational amplifier? Because it does many operations like summing amplifier, difference amplifier, integrator, differentiator. It can be used as an inverting amplifier, non-inverting amplifier. So the name is operational amplifier. Now I would like to show you the pin diagram of IC741. So this is a pin diagram of IC741. Pin number 1 and 5 is offset null. If any circuit without input, if there is an output, that should be nullified. So with the help of pin number 1 and 5, we can nullify that output. Pin number 2 is inverting terminal. Pin number 3 is non-inverting terminal or inverting input and non-inverting input. It works on dual power supply. We require positive and negative supply. So pin number 4 is for negative supply and pin number 7 is for positive supply. Pin number 6 is the output pin, wherein we can see the output at this pin number 6, and pin number 8 is not connected. Now we will see first experiment or first part, which is inverting amplifier. This is circuit required for inverting amplifier. R1 is the current limiting resistor at input side. RF is the feedback resistor. Amplifiers requires negative feedback. Some part of output should be fed back to the input, so we are providing that with the help of this feedback resistor RF. See here, pin number 2 is inverting terminal. We have given input to the inverting terminal. Pin number 3 should be grounded because this is again input. At a time we can give input to one terminal only, so pin number 3 is grounded. This is non-inverting input. Pin number 7 is plus VCC. Pin number 4 is minus VE. Pin number 6 is output pin. So this is about the circuit diagram of operational amplifier. Now these are the waveforms, input and output waveforms. This is input waveform and this is output waveform. From waveform, it is clear that output is out of phase with input. There is 180 degree phase shift. For positive peak, we are getting negative peak. Output is amplified version of input, but it is inverting. Why? Because we are using inverting amplifier. So output you will get in inverted form only. Gain of this amplifier is decided or it is calculated with the formula minus RF upon R1. RF is the feedback resistor and R1 is the input resistor. So what is the important thing or what is the beauty of this IC is, by adjusting external component we will be able to adjust the gain of the circuit. So output is equal to gain into input. So output will increase or decrease depending upon gain, and gain will be adjusted by adjusting external components. So we can have any gain by adjusting the RF and R1. Now we will see the next part, which is the non-inverting amplifier. This is the circuit diagram of non-inverting amplifier. Again, this is R1 input resistor, RF is the feedback resistor. This time we are giving input to the non-inverting terminal, that is pin number 3. Pin number 7 VCC, pin number 4 minus supply, pin number 7 plus supply, and pin number 6 is output as it is. And these are the input and output waveforms for non-inverting amplifier. For positive peak, we should get positive signal, because this is non-inverting means signal will be same, shape will be same, but it will be in amplified version only. Because this is amplifier, we should get output in amplified form. And the gain of this amplifier is calculated with this formula. Gain is equal to V0 upon Vin, output voltage upon input voltage, which is equal to 1 plus RF upon R1. So it is obviously greater than 1. Again, by adjusting RF and R1, we can have different gain. Now experimentation part will be explained by the Birada madam.
Good morning all of you. Now theoretical part is explained by Smita ma'am. We are going to perform inverting and non-inverting amplifier. The apparatus required to perform inverting and non-inverting amplifier are: first, function generator; second, CRO, that is cathode ray oscilloscope; then we need a dual power supply; then we need a inverting non-inverting amplifier kit. We'll see one by one. So this is a function generator. From this we are giving the input to the circuit diagram. So next, output of the circuit diagram is observed on the CRO, that is cathode ray oscilloscope. Now we'll come to the power supply. We know that we require two power supply, that is plus VCC and minus VEE. So we need, this is one power supply, this is second power supply. So the connection is plus of the first supply, minus of the second supply should be shorted, Then negative of the first power supply is connected to pin number 4, that is minus VEE. Positive of the power supply is connected to the pin number 7, that is plus VCC. This is power supply connection, and this will be the we are connecting to the inverting and non-inverting terminal, that is IC741. Now we will explain. So this is a function generator. So this is the input signal and this is the output signal. I am varying the amplitude of the signal. We can see that input is varied. Similarly, the output is also varying. So now from the output, it is very clear that we are performing non-inverting amplifier. As I said, this is input, this is output. Output is in phase with the input, and also the output is amplified version of the input. So this is the waveform. So while taking the reading, what we should perform? We have to calculate always theoretical and practical part, and we have to compare both. Theoretically we have a formula. So this is for non-inverting. So 1 plus RF upon R1. With the help of the components values RF and R1, and with the formula 1 plus RF upon R1, we have calculated the gain. And practical value, we have to take the input reading and the output reading. So gain V0 by Vin should be equal to 1 plus RF by R1. So this is about the non-inverting. Now we will perform the inverting. Only thing is we need to change the input. So we will change the input. So we are giving input to the inverting terminal now. We are giving input to the inverting terminal. So everything remains same as it is. We can vary the amplitude also. Now again, so this is input, this is output. Now output is inverted version of the input. So this is output. It is 180-degree phase shift with compared to the input. Also it is in the amplified form. So just see here, I am varying the input, we can vary the output. So by this we have to take input reading peak to peak, output reading peak to peak, then calculate the gain 1 plus RF upon R1. This is inverting, we have to go for the calculation formula minus RF upon R1. That should be equal to the V0 upon Vin. Thank you very much.